How to verify whether your microwave link has a clear line of sight using Spectrum Compact. Clear line of sight is critical for long-distance microwave point-to-point link performance, so it is highly important to make sure no object interferes with the signal, as any unexpected performance issues may result in new expenses and necessary changes in network topology later on. Even if the remote site seems visible, radio line of sight may be affected by an object within the so-called Fresnel zone, an elliptical area immediately surrounding the visual link path, which varies in width depending on the link distance and the frequency channel. For example, if a hard object, such as a mountain ridge or building, is too close to the signal path, it can reduce the strength of the radio signal, and the planned received signal level will not be achieved, even though the obstacle does not obscure the direct visual line of sight. Therefore, the necessary clearance for the Fresnel zone must be calculated and taken into account when planning the link path. SAF's line of sight verification kit is designed specifically to perform this task as quickly and cost-effectively as possible. You will need SAF Spectrum Compact Signal Analyzer device, SAF SG Compact Signal Generator device, 2 antennas, 2 coaxial cables, 2 compasses, 2 spirit levels, 2 waveguide adapters. 1. Calculate the path budget with a professional radio link design and planning tool to determine important values such as azimuth, elevation, frequency, polarization and target received signal level. Use SG Compact output power, chosen frequency and the particular antenna's gain in your calculations. 2. Determine the direction towards the other site before climbing the tower. Use a compass to find the right azimuth angle and look for something in the environment to use as a reference point when you're up in the tower. 3. Climb the tower and install the antenna at the chosen height and polarization. Set the horizontal direction of the antenna according to your previously chosen reference point. To make sure the antenna points straight, use a spirit level tool to adjust the vertical angle of the antenna to be 90 degrees relative to the ground level. 4. Repeat step 3 on the opposite site. Make sure that both antennas are installed in the same polarization. 5. Connect the SG Compact to the antenna at the first site. Set center frequency and power on the SG Compact unit according to the calculations done earlier. 6. Connect Spectrum Compact to the antenna at the opposite site and set the same center frequency as on SG Compact and adjust span to minimum. The SC and SG frequency settings must match. 7. If the initial alignment was done correctly, a signal trace should appear on the SC display. To reduce the noise effects, use average mode. The recommended setting for a line of sight survey is average 2 or average 4. 8. Measure the incoming signal strength by pressing the Power in Band button and setting the bandwidth to 4 MHz. 9. Proceed with fine-tuning the antenna alignment on the Spectrum Compact site. To find the maximum received signal level, adjust the antenna horizontally. Once the maximum signal is found, fix the antenna in that position. 10. Do the same for horizontal alignment on the SG Compact site and fix the antenna at the maximum signal level. 11. Align and fix the antennas vertically in the same manner. 12. Verify the line of sight. If the maximum achieved received signal level is within 3 dB of the calculations, there are no obstacles within the chosen link path and the line of sight is verified. If the deviation is higher than 3 dB, the line of sight is not clear and you should consider changing your network topology. SAF Spectrum Compact, designed with field engineer in mind.